you can proceed.
So today we'll be covering ADTs, abstract data type. So in Python, so there are basically three types. One is tuple, then list, and lastly dictionary. So in terms of C concepts, you can think tuple and list as arrays, and say all the properties of arrays like 2D, 3D. It can like all the properties can be applied to these two entities. And finally, the dictionary can be thought of as a map, hash map. Okay. So now the ADTs, like, so the general concept of an ADT is basically, wait, so let me just connect my graphics pad, then it will be easier to explain. Okay. Share screen. Okay. Okay. So ADTs are, as we saw, basically three types: tuple, list, and dictionary. And like the definition of ADT is, they have two main properties. They encapsulate data, or yeah, data, and provide methods or functions to access or modify the data or the internal data structure. Okay, so they can encapsulate data in any structure. For example, tuple and list, they both capture as a array of entries, and then directory will contain as a hash map, so like key value pair. So the main data structure there, key and value, and then you have multiple rows of that same structure repeating, so multiple values can be stored. Okay, so so now we can see how we can leverage these things in Python for the debate. Is okay, this is okay. New directory. Now first data structure will be, or abstract data type will be list. the list. So if I just type list, you see this is already a keyword in Python. So it knows that, or it actually like recognize this word list, and what it recognize, if I just call and so it's actually recognizing the list constructor. So if I just pass any iterable, so iterables are, or anyway iterables can be defined with this bracket and close. Okay, so just like tuple. So iterable is equal to, it's a 1 2 3 yeah, no need to name that. Anyway, so iterable, so now you see this, after passing an iterable inside a list, we get a list. So the represent is with third bracket. So look, there is another way how you can initialize lists, is by directly by using the third bracket. So if I can just do 1 2 3 4 5, that would also work. So this is also indirectly called the list constructor, and then like generate, make this list. Okay, so now if I want to just store in a variable, so it is just same as how we are doing for integer and other data types. So L equal to 1 2 3 4 5, so L is a list. Fine. Now if I want to check or ensure whether the type is list or not, we'll just do this. Okay, type is list. Fine. Now we already know that the list data type is actually like organizing the data in a array format, right? So we can access their elements with the array notation itself. So li, so I can be anything from, okay, the index. So for Python, index is something like the same as string. We also discussed this indexing in case of string. So it starts with 0 and ends with the length minus 1, right? So the length, this would be n length, right? And then so one way is to index from left to right, then it will be 0 to n minus 1, or you can index from right to left, then index will be minus 1 to here is minus n. Okay, if you index from right to left. Fine. Okay. Now if I want to access, let's say 3, so what is the index? 0 1 2, right? So 2 3, okay, so I get 3. Now if I want to access 5, I can do 0 1 2 3 4, or what I can do is L minus 1. Yeah, both of them returns 5. Cool. So now we can access the elements of a list, right? Now we'll see what are the functions associated with list. If I just call dir on the list abstract data type, you see this returns me all the functions that are defined within that class. So you already know this doc thing. This is a variable. This is not a function, I guess. So it contains all the variables as well as the function. Just like this doc variable would print the dot string or something, right? Size of another okay, kind of this. Now the main functions that we can observe from here is this. So one thing, Python actually cannot have private functions and all these things, right? So whenever we want to hide a function, we have to have this underscore in the beginning, so it will not come as a suggestion. So let's just see list dot. If I just do tab, only those functions will come which don't have any underscore in the prefix. Okay, so that's how we hide functions from the user. But anyway, user can always see them or call them. They can be called, but we can hide them intentionally if we want. Okay. So now append. So we have these functions, right? Copy, paste. Cool. Now append function, what it does, it just acts like the list just acts like a linked list. So I can add any element at the end of the linked list, right? So L, if I want to add, let's say 12 at the end, append 12. Now this function itself return nothing, so nothing gets returned, but the L context, so the L is pointing to some memory in RAM, right? So that memory gets reallocated, and 12 is 12 is included at the end of the memory. So if I just check L, so still L has all the previous values and only 12 is added. Okay. Same thing if I want to let's say so append always append means it always insert the new element at the end. So this one is complete, right? This one is complete. Now if I want to add in any location, right? So then we have a more generic function, insert. So insert takes two things, index and an object. So index would be in which position or which index we want to add, and then object would be anything, integer, float, anything. So one thing I forgot to mention is this list don't necessarily have only same type of data. Okay, it can be having integer, float, string, any object, another your custom defined objects and all together. So just like this, let's say 1.12 67 and let's say 90.78. So three are different data types, right? So if I can also have their list as well. So data types are so element data type is not necessary for a list. Okay. So insert I let's say I want to insert in the second position, so index will be 0 1, and I want to insert 100. Same thing, nothing gets returned, but L has been changed. See, second position 100 has inserted, right? So insert is done. Okay, so append actually is just like a push function, right? For stack. So the opposite function is pop. So if I just do pop, it actually it can delete from any location, but by default it deletes from the -1. Okay, so last element will be popped and returned, and the list will be changed. So 12 is popped and the list has been changed. 12 is not there anymore, right? Now if you want to remove at any location, then a more generic function would be remove. So remove takes the value, and right, remove takes the value, and then whichever is the first occurrence, it deletes that element, right? So just let's say if you have 200s in the string in the list, then the first 100, if I just pass 100 here, the first 100 will be deleted. Okay, cool. So it's down. Okay. Um, Now index function is something if you want to find the value, find the index of any value. Let's say I want to find the index of 4, right? It will give me 3. So 0, 1, 2, 3. Yeah. So the index of 4 is 3. Fine. Index is done. Extend count. Okay. Count means how many elements are there. Okay, no. Count means which given a value, how many times it occurs. Let's say 2. It occurs 1 time. So if I just add another 2, count 2, right? Now see if I just print L here before running that, it has 2 2s, right? So now if I count number of 2s, it's 2. So count is down. Reverse sort. A copy clear is something like if you want to clear a list, remove all the elements. Let clear and then check L. Nothing is there, so all the elements will be removed. Copy means it's actually deep copy. So so what happens, because these lists are actually handled by pointers, if you just reassign their let's say if I do something like this, L equal to 1 2 3 and A equal to L. Now if I only change A, L will also get changed because A and L points to the same entry in memory, right? So this happens because the list data structure is getting handled by underlined pointers. So if I want to not have this aliasing property, right, this called aliasing. If I want to have different memory blocks for A and L, then what I can do is there is 2 options. If I can do this, L copy. So now what it does, after copying L, it creates a new entry in memory and then A points to that new entry. So now A and L are 2 different entries in memory. So now if I only change A will not change, but A would change because these are 2 different memory locations they are pointing to. Or instead of copy, you can also have this. This is a copy operator. So we'll show sizing. Then this will be more clear. So this would also work. Same. Anyway, we'll just stick to copy. Copy. And extend reverse sort. Okay. So what we can do is 1 2 3 4, and we can add with another list. So what happens if the list is getting concatenated? Same thing. This same thing is represented by extend. So extend the list with a list. So the given list will be added at the end of the current list. So yes, let's say I want to add 100, 101, 102. L. Now see, L previously was 1 2 3. Now after running this query, we have all these things added at the end of the L. Fine. Extend is done. Reverse, as you can already understand, reverse means it will give you reverse of the list, and it actually changes the list in place. Okay, see, reverse the list in place. And lastly, sort. So L dot sort, it actually sorts the elements. So in place, obviously, and see everything gets sorted again. So just for another example, let's say I have 9, 7, 3, 10, 12, 3, 2, 1, right? So now if I sort, and the main so it sorts in ascending order, so from low to high. L. Now see, everything gets sorted from 1 to 12. Okay, so these are the main primary methods or functions we have available in with list, and we can change their internal data elements with all these functions. Now in terms of accessing one thing, we can, so for accessing one element, we already saw that you can access it by index. But if I want to access a chunk of element, let's say I want to access from this 3 to this 10. Now which index to which index? 0, 1, 2 to 3, 4, 5, 6, right? Okay, so just as the string indexing works, it works similarly. So from 2 to, not including the last element, so I will say 7, so it will go up to 6, and so now we have a chunk of that data, right? Chunk of the whole data structure. So now similarly you can have 2D list, and also 2D list just looks like list of list, right? So 1, 2, 3, and then 6, 5, 6, 7. So yeah, so this is a 2D list. So you can access, let's say I want to access 5, then I will do something like this. So the first index will be I want to have the first list and then the 0th element, or zero, the second list and the 0th element. So index will be 1 and then next index will be 0, 2 times indexing, and it gives 5. Okay, so this is all about list. Now if I want to go for tuple, oh sorry. Okay, so tuple is something like t is equal to, it defines similarly as list but works little differently. So uh, curly like first bracket. Okay, so 1, 2, 3, 4, 5, same thing, let's say. So type of t is tuple. Now you would say that okay, these two data structure looks like almost similar, so why do we have tuple then, right? So tuples are there because they are immutable. So in case of list, they are mutable, right? We can change their index and modify any part of the data, right? But in case of tuple, whenever a tuple is initial values, and then if I want to change them, I have to create a new tuple. Okay, so no aliasing happens here. If I just, like, aliasing can happen if I just do this, but you cannot change the value, so it doesn't have any effect. Okay. So you can actually have the element, we can access the element similarly in similar to a list. Let's say I want to have the 0th element 1, fine. Slicing would also work. So let's say I want to slice up to fourth. Now, like up to third, so I will give fourth. So yeah, so 0 1 2 3 0 1 2 3, right? Now the functions available with tuple are all these. So you see, most of the functions are not there. So only you can, none of the modifying function, whichever modifies the data elements, that's not available for tuple. So only these two count how many repetitions you have for a single value, and then what is the index for a value. These two functions you can only have, right? So it works similarly actually. So count, let's say I want two files. Now, oh sorry, now if I do t dot count 5, it will give me 2. And if I want to do t dot index 4, it will give me 3 because it's at the third index. 0 1 2 3. So these two functions work. Any other functions which are associated with list would not work because the data type is actually immutable. You cannot change the element. So example could be, if I want to change let's say the third element that was 4 previously, I want to change it to 100. So if I do, see, tuple object doesn't support any item assignment. So if you want to do that, then you have to do it like this. T, you first slice uh, from sorry, T, you slice from 0 to before 4 means 0 1 2 3. Okay, 0 1 2 3. So it's sliced from 0 2 before 4, and then you add 100. This is how you will define a single element tuple. As the same thing works for single element list as well. Plus T 4 3. So third index we are skipping, then 4 to 4 to end. So if I just don't give anything, it will consider end, right? Yeah. So now if I want to change the value to 4, then I have to run this statement. So it creates a second tuple with the modified value in where the 4 was before, right? Yeah. So this tuple and this tuple is not same. They are pointing to very different memory location in the RAM. But in case of list, you see, they can be aliased. So if I change here, it will be, so I can directly change the memory location. But tuple don't allow that. So one thing we can call both on list and tuple is length. Len function length can be called on both on list and tuple. So you can say, if I just want to check the length of T, it would be what? 1, 2, 3, 4, 5, 6 elements, right? 6. Yeah, 6 elements. Same thing if I want to check the length of L, it's 2 element, right? Let's see L. Okay, so it's a 2D list at this point. So now it only get length for this first list. Okay. So if I just make it a 1D list. Yeah, now the element is length is 4. Now another function, another two function which comes really handy time to time is min and max. So min function gives you minimum for both tuple and list. They all. Max function give you maximum. Okay. So and another is mean. No, so mean is not present, I guess. No. Sum function. So it sums all the values. Okay. No, cumulative sum is not there. Maximum and sum, they work for both tuple and list, and they come really handy because you don't have to run a loop and then sum or get minimum or get length, right? So you can directly call the function and get their values. Okay, cool. Now the last data type is dictionary. Oh, sorry. Yeah, dictionary. So dictionary is actually a key value pair, and then it is defined like this. So second curly braces, and then you have to give key colon value, and then you can give comma and then do key 1 colon value 1. Any other, like if you have, sorry, um, if you can have other values too, you can place them like similarly, comma and then key colon value. So the constraints are key should be immutable. You cannot have any mutable data type in key. So mutable data type means you only have list. So you cannot have list. That's it. Okay. Cannot have list, and then your user defined data types you have later, classes and all, right. So those cannot be also in key because they can change, right? Fine. Now key should be immutable, so integer, all the basic data types, actually basic data types except float. Float cannot be made as a key. A basic data type except float, um, plus string plus tuple. All these things can be can act as a key, and then value can be anything, any data type, anything you define in Python, right? So for simplicity, we'll just, let's say, do this type of assignment A1 B2 yeah. So you see, this is a dictionary. Let's name it as, like, save it in D, and then if I just check the type of D, it will be dictionary. Now now how to access the elements? So in case of list and tuple, we have indexed default index values, right? It starts with 0 and then ends with in -1. But here we actually defining the index, so this key is actually the index. So same notation would work. If I just do a here, it fetches back the value corresponding to a. So just like a hash map, so it maps get this key and then find the occurrence in the whole hash map and then get the corresponding value, return that. So a having value 1. Fine. Now uh, so dictionary is actually immutable, so I can change the value of a to be 100, just like this, and then it gets changed. Now a has 100. Okay, so the length function also work here, how many entries you have for D, but the minimum maximum and all those things doesn't work. Okay, because it is not something you can directly call minimum, maximum, or sum of them. Now let's see what are the functions available for dictionary. Oh, these are the functions available for dictionary. Okay, so clear, copy, we already know. These two already know. Others also. Okay. Now d dot get, it expects a key. So d dot get means it will get the corresponding value of a key. So if I just pass a, it will return 100. Fine. Uh, items actually, it, see, d dot, it actually gives you a iterable of tuples. So you see, so dictionary can be cast to a list of tuples. So all this key value pairs are actually acting as a tuple, right? So first entry will be the key, second entry will be the value. So now d dot items will give you a tuple like this. So when it will be handy, let's say I want to iterate through the whole dictionary, right, with key and value. So I can do it like this. Yeah, see, I can do it like this with the items command. Now if I want to check all the keys, so I can run this dot keys, then it will return me all the keys available in the dictionary. If I just do key values, so it returns me all the values in the dictionary, right? So keys, okay. Now pop adds something similar to what we saw in list. It actually pops a key actually. So if I just do, no, let's see, if I just want to pop B, right? So it gives me 2. Now D has been changed. B is not there. Previously B has the value 2, right? So we remove the key, the entry for this particular key, and then the value gets returned with the pop function. Now pop item means it will directly give you the tuple, key value tuple. Okay, set default, I don't think anything we use these functions too frequently. Update function, let's see, d dot update, what it expects. So update d, iterable e and f. No, I don't think this function gets too many time used. So no, we can do any. So we can do the similar thing with other ways. So no, don't need to use this function. You get it? Okay, fine. So what we, so these two functions we can remove safely. And copy function. So because this is a immutable data structure, so and the value, the dictionary is also getting handled by underline pointers, so the aliasing problem happens here as well. So if you assign the dictionary to another variable and then change that variable, the initial dictionary would get changed unless you uh, intentionally copy and create another entry in memory. Okay, now what are the operations we can do on all these three data types? So I can, so logical operations, in terms of logical, I can see whether an element is present in all of them. So for list, so what I have in L, so for list, if I want to check whether 5 is there in the list, so 5 in, so the keyword is in, so 5 in L would return me false, so 5 is not in L. Okay, but 4 in L, 4 in L would return me true because 4 is there. Same thing works for tuple 2. Let's say tuple. Okay, now if I want to check 6 in T, it gives me false. If I want to check 2 in T, it gives me true. Right? Same thing for dictionary, it would be keys. So I will have to check against the keys whether a key is available or not. So dictionary, we have A and C. So if I just check B is B in dictionary, because we already popped that entry, it gives us false. and then if I just say if C is available in D, we can have it's true, right? Right. So now if I want to add B again, what I would do, I would, yeah, I'll do like this. So dB is equal to 100. Let's say 100. 4. No, 6. Okay. So dB 100. Now after executing this line, see the B is again added. So now checking whether B is available, this would return us true. So this is how the base. These are the basic abstract data types we are having in Python. So basically, these with these data structures, we can store and arrange our data elements in such a way that our computation gets faster. Okay, we don't have to implement or uh, have our own implementation of hash map and all these things. We can directly use the dictionary. Okay. Yeah. So I guess we can stop here, right? Sir, just tell me whether you want to see some examples or not, or you can stop. So you want to see any example, particular example, how we can implement with dictionary list or tuple. Okay, anyway, so I just show a simple example then. Right. Uh, okay, now let's just let's have mm, so let's frame the question such a way that you have names of thieves and their properties, right? Properties in terms of list, or we can actually implement dictionary of dictionary. So we can have dictionary, and then the values could also be having a dictionary, right? Anyway, so we are doing a log for, like, let's say a log book for thieves, which the first entry would have the names, and then corresponding values would have the properties of the thief. And after that, we'll kind of narrow down our search based on our requirement. We want to find a thief, and then let's say get that thief out, right? So you want to search the whole logbook and check whether this particular properties match with any thief or not, right? So let's have 3 thieves then. D is equal to, let's say P1, or let's say T1, thief 1. Corresponding value is another dictionary having what age, say 22, height, let's say 150, and then let's say weight, let's say 57. Okay, so I can just copy this thing and change the values. I don't have to write it again and again. So then I will do a comma and then enter and then paste the same entry. I just modify the values again. Fine. Just yeah. Now let's say the T2, T2, T3. Let's say it has age 31, Now thief3 has age 15, height would be, let's say, 170, it has height 130, age 75, and this age is 45. Fine. So now you see, we can have dictionary of dictionaries, right? Now I want to search. So the thing is, I want to have the thief name of which has age less than uh, 25 and height. No, weight greater than 50. Yeah, so I want to have this logic, right? Now you can say that from seeing the entries I can see that T1 is the answer, right? But when you have millions of these type of entries, you can have multiple matching, so multiple can match, like fall under this category. So just let's add another three that falls under the same category. T4, let's say its age is 23, and then this is 75, or let's say 72. Cool. Now, yeah, so now two entries would match this condition, right? T1 and T4. Now in computational, we have to find it. We have to look through the whole dictionary and see. So we'll do something like this: for key, comma, value in T dot items. So now, so what these two, sorry, key, comma, value. What these two loop is this T1 and then the whole other dictionary, right? So now I can do another level of looping. Key1 value 1 in, or because I have already a dictionary, right? Value is already a dictionary, so I can check and I can get those value age and weight from V itself, right? This is prop dict. Let's rename the value, and this one is thief name, thief, right? So yeah, so now if I can check this thing now, see, I can copy this and do something like this: prop dict, from the property dictionary, get the age, and from the property dictionary get the weight. And now if the whole condition is true, then print the thief name. Yeah, if I just remove this, you see T1 and T4 gets printed. So this is how you actually organize your data so that your computations get easier, or you can see, right? So if like how else you can arrange this data so that your to determine whether a particular thief is falls under any of the age and weight category, the code will be smaller. So it's the smallest code you can have, right? Only one loop, one if else, and then print. That's it. Okay. So yeah. So another thing I actually forgot to mention is list comprehension, but that's actually an advanced topic. So we'll touch upon that later on. So it's something like this. So so if I want to create a list from, let's say, 1 to 100, so what I have to do is I can have this, like this type of statement: list of, I can cast a range to a list, right? So 0 to 101, so it will give me a range of 100, so 0 to 100, and then I cast it to a list. If I check, so now it has all the values, right? But not always we'll have a like this type of linear range. So let's say I only want to have the odd values, right, or even values in a particular range. So what I can do, I can do something like this. So for element in range 0 to 100, let's say 101, so 100 it will loop. And then if I only, and here I will, what would be the array element? So E would be the array element. I loop through the whole range here. So if I only just only run this, then it will give me the same value 0 to 100. Now one thing I can do, I can have constants on how when we emit E in the list. So that would come here. If E modulo 2 is equal to 0. So now we have only odd values. Hey, sorry, even values. Now see, it only emits even values. So now 0, if you want to skip 0, then starts with 1. 1. Yeah. Now see all the even values that can be possible within like 1 to 100 is printed with only one line, right? So this is actually advanced topic. You can have loop like nested loops and all those things, and have really complex let's say 3-4 line looping and all this in one sentence actually. So it's compress the code to a certain like to a like, significant degree. Okay, but anyway, this is not necessary, like not necessary for all the cases. So you can always write whatever you are doing with a list comprehension in a more let's say like expanded form in terms of loops and other if else conditions. Okay, but yeah, so these actually comes handy when we will be doing pandas. So pandas is for let's say for data processing, we can have small codes, right, so that we can understand, right? Don't have like, because already the data processing steps are really big, so we don't want to have too much complexity in terms of looping, and also we just use sometime in place this list comprehension methods so that the code become crisper. That's it. Okay, I guess we can close, right? If anybody have any questions, just tell me. Otherwise, you can close. Okay, so we already covered all the abstract data types for today's class, and then in the next class we'll have a case study or something. So for some sample examples, we'll show how to use these use these data types, and next we'll build our own data types for classes and all. Right? Yeah. Okay. Gunjan. You can stop. Right. Yeah. Let me just stop sharing. Okay, goodbye. See you in the next class. I'm closing.